Welcome friends. Today's we will see the logical data recovery. In that we will see the chapter 5 how data store in the hard disk. We already seen 1, 2, 3, 4 chapter. Now we will go on the 5th chapter. The 5th chapter is for how the data is stored in the hard disk. That's the basic introduction. When we delete, what happen, and when we recover that software base, what happen, like that. So we will go step by step. First, how the data is stored in the hard disk. What is a FAT32, NTFS and XFAT? We will see later. This is our first stage. We already explained how we are giving an address to the locations. Here is your address of our hard disk. The 0 is for MBR, master boot record, and others we have a space. So it will be busy. So these will be busy, and another we have a space, free space. So all whatever the space is busy, it will denote like this. Be free, it will be denote like this, and it shows the next perpendicular area. Okay, so we will go step by step. First we will see this is our how data store in the hard disk, first stage. Second, when we go, we will write one file abc.xyz. We have created one file. This is our new hard disk. There is no data, and we created one file that is an abc.xyz, something like this. First of all, we explain about what are the sectors and what are that. So from where abc start, this is first thing. We create one file which has an 3 sectors. One sector has size. What is different, we will explain you 1 minute. So we have creating one file abc.xyz. Then we will go, it has a size, abc.xyz has 11 KB. Here one sector is equal to 512 bytes and one cluster is equal to 8 sectors. So minimum file space allocated to one file is an 8 sector is equal to 4K. So minimum one file or one blocks are of 4K. So here we have a different blocks. So we occupy 3 blocks because here is a 11 KB. So we occupy one block, one sector of 4 KB, another sector of 4 KB, and third sector is up to here, that is a 3 KB and 1 KB. It will not give anyone to use it. That is a file slack. We assume that this is your sector. Anyone is the sectors. So this is your 4 kilobytes, 4 kilo, 4K, 4K, 4K size. In that whole from starting to end use, here starting to end full, from starting up to here it is full, and this is free space. We cannot use for any other purpose. So it occupy the 3 blocks, and these 3 blocks store starting from second. So he has taken the second sector as a free. So he have taken here as a second is a first. He start from here and he allot these as a space. So and another free he got 5. So 5 is also he has taken. Then third he has taken 8. So 2 next is 5, 5 from next to 8, and then -1, that is an finish. So he has started the cluster from 2, first ABC here, second on the 5th ABC here, and 8 here is an also ABC part 3. 1, 2 and 3 like this. It occupies the 3 sectors. Sorry, not sector, it is a cluster, one cluster. So here he will mark 2 as ABC file. There is a one free space table where we have all the cluster address, and here it occupy the 2, so it make it as a 0, that my 2 is occupy. Then here the next cluster where he has to skip, so here it has marked as a 5. Next he will go from here to 5 like this. Then here it will go to 8. It will go to 8 sectors, and here is a stop, means my file end. So my this is occupy as a 0, as a 0 and as a 0. That another when I write any other thing, this will not use. Whatever is 1 is an empty, and 0 means fill. So whatever the 1 is there, there we can note another data like that. So here is a 0, 0, 0, that this cluster is busy, so it is 0. Okay, next. So this is first step. We write the file abc.xyz, that is an 11 KB. So it occupies in a hard disk, when we see it occupy 10 KB, 12 KB, but file size is 11 KB because it occupies the 3 blocks. So 3 blocks is equal to 12 KB. So it store in the hard disk 12 KB, but originally its size is 11 KB. So this is one space. Next we will go further. This is the process of one file writing. Next, now file has written on the disk. It has been written here, here, here. We delete the more functions. See, ABC is here, part 1, ABC part 2 here, ABC part 3 here. It also occupy here, and here also it has been written. Now suppose we want to delete. We want to delete the ABC file. What happened? We have to delete the ABC file. We give the command delete abc.xyz. Then we can recover or not. In that condition, we will see later. We give the command delete abc.xyz. After delete the file, remove from the file allocation. It will remove from this file allocation table about the ABC, and it make this space as 1. Before that it is 0. Now it has free space. It allowed the use of ABC files as a 0. Before that it is 0. Now it has make 1. So that when I write any data, it can occupy this space also. But my ABC, whatever the cluster is there, it is stored here only. Till it is there, till we don't overwrite any other data on this cluster. So if suddenly I have deleted, and if I want to recover now, if I use any recovery software and recover the scan all the cluster, then this file will be recovered. If it is not overwrite, then the data will come. If it is not in FAT also, but he can recover and he can give as a deleted file that ABC is deleted like this, XYS like that, it will mention here. So the logical recovery is the same process. If the data is deleted and not overwritten or not write any data, then it will be recovered very easily. But second option, if data is overwritten, we will see later. Next we will see data will be there on the platter, and it can be, we run any recovery software, it will recover this file. Now we write one more file. We write defxxx dot, which starting cluster is 6, as a 6 is free, so he has taken the 6 as a starting, and total number is 3 cluster size. So DEF is a 9 KB file, so it will occupy already 3 sectors, 3 cluster. It give a name 6. He found 6 is okay, then he takes 6. Then he found 5 is also empty. Then also he will take 5. and then it next portions he has taken 12. 5 and 6 to 5, from 5 to 12, 12 to minus 1. It has written, so he has occupy 5 as a 0. Next, sorry, first is 6. The 6 they have mentioned 5, then it go 5, then it go to 12, then it will be minus. So here it is occupy. So what happened? Now this DEF, is written here also. DEF written on 6. This is your DEF. Then this old data is written, overwritten, and it is written with the DEF, and here also 12 it is written DEF. So now it is possible to recover the old file. Okay, the old file will recover, but it will be corrupted because it has a 3 cluster, one cluster is overwritten. So in this case, if there is an image, then what happen? Image will come like this, half will come, half will not come, and half will come like this. This is come, this not come. If doc file or XLS file, it will be corrupted because the whole 3 cluster has not come. In between 5 cluster it is damaged. So this is possible when we overwrite any data, the file may become in a corruption or not backup or nothing will show. So this is our recovery option. Next. So this is one options. What is the option here? Now it is possible to recover ABC file. Not possible. Maybe file come, but it will be corrupted. So file ABC can be recovered but may be corrupted. Okay. Next. So here are the directory table, different tables are there. So normally we are explaining, this is first portions about the data recovery. Now we will see what is an MBR and what is a boot sectors. MBR, boot sectors of partition 1, boot sectors of partition 2, boot sectors of partition 3. Always MBR is in 0. You can see here is a 0. 0 is what? What we have seen, the sectors are like this. Clusters are divided like these sectors. So 0 sectors are always MBR, and if new hard disk, then remaining 32 they are GPT partition. Then first partition will be approximately 2048. This is your first partition of C drive example. So here is the first partition. It is a 2048 starting of the first partition. Then maybe depend on the size of C drive, then another boot sectors of D drive, then another sectors of E drive, like that. Depend on the size of the C partition. But you can see MBR or boot sector. If MBR is corrupted, then partition will not show, and if this boot sector is damaged, then these files will not show. So directory table of different partitions. See here he is making a different size of partition. So depend on the partition, they are here. 2048, first system partition, second small partition, and this is a big partition, like that. So these are the partition gap between different folders. Next. We have to repeat again and again same thing. See, this is also file allocation table, FAT. Whatever the partition is occupied, it will put 1, and if not occupied, it will put 0, like this. Occupy, not occupy, busy or not busy, like that it will occupy. Like. So file, it will be allocation. Free boot record tools is a free table where we informations about the free space table. There are different type of FAT, say 12, FAT 16, FAT 32, old one. File allocation table, variants are 12, 16, 32, each of increasing number of cluster and maximum file volume size. Then NTFS, new technology file system, file size limit is 16 exabytes, generalized file system to avoid the corruption, support of permission and encryption, Windows must be installed on NTFS drive, limited non-Windows. Then EXFAT, extended file allocation table, okay, maximum files is 16 EB default. Then EA extension 2, extension 3, extension for Linux, HFS, Mac OS, okay. Then ZFS, Z file system. These are the different type of OS. Okay, so this is the process how the data is stored and format, deleted, MBR. These are the different process in the logical recovery. Next portions we will see what are the format, what is the MBR, what is the system file, and all those things, and we'll see on the next videos. Thank you. Okay.